to prove n of q is not equal to n of p, here we construct a continuous function alpha from closed interval ab into Rn plus 1, which is differentiable at a and p such that first condition alpha of a equal to p, alpha of b equal to q, and alpha dot of a equal to pv, and alpha dot of b equal to qv, and alpha of t does not belongs to S for a less than t less than b. Suppose we have constructed such a function alpha, and if n is equal to del f by norm del f, we have f composition alpha dash of t is equal to del f of alpha of t dot alpha dot of t. By using this, we can say that f composition alpha dash of a is equal to del f of alpha of a dot alpha dot of a. And by first condition of alpha, we can say that alpha of a is equal to p and alpha dot of a is equal to pv. Hence, the equation will be del f of p dot pv. And here n of p is equal to del f of p by norm del f of p. So, del f of p is equal to n of norm of del f of p into n of p. Hence, here it is equal to norm del f of p into n of p dot pv, and it is equal to norm del f of p into n of p dot v, which implies f composition alpha dash of a is equal to norm del f of p into n of p dot v. Similarly, we can say that f composition alpha dash of b is equal to norm del f of q into n of q dot v. We need to prove n of p is not equal to n of q. To prove this, suppose n of p is equal to n of q. Then when we consider these two equations 1 and 2, we can see that here the sign of f composition alpha dash of a depends on n of p and n of p dot v, because here norm of del f of p is a positive value, and here the sign of f composition alpha dash of b also depends on the value n of q dot v. And since n of p is equal to n of q, we can say that f composition alpha dash of a and f composition alpha dash of b will have the same sign. And also we know that f composition and here the function f composition alpha have the same sign at the points a and b, which implies that f composition alpha either be increasing at both endpoints or be decreasing at both endpoints. Consider the graph of this function. When we look at this graph, since alpha of a is equal to p and alpha of b is equal to q, we can say that f of alpha of a is equal to c and f of alpha of b is equal to c. And suppose this function f composition alpha is increasing at both the endpoints, and then here the function is increasing and at p the function is increasing. We can find a point here. F composition alpha is a strictly increasing function at both a and b. So we can find a t1 and t2 in the open interval ab such that f composition alpha of t1 is greater than c and f composition alpha of t2 is less than c. Since f composition alpha is a continuous function on the open interval containing T1 and T2. By intermediate value theorem, we can say that there exists a T belongs to AB such that F composition alpha of T is equal to C. And we can say that there exists a point T belongs to AB such that F of alpha of T equal to C even if the function F composition alpha is decreases at A and P. And F composition alpha of T is equal to C implies that alpha of T belongs to F inverse of C, which is equal to S. That is, there exists a point T belongs to open interval AB such that alpha of T belongs to S, which is a contradiction to the second condition of alpha. Since it is a contradiction to the second statement, we can say that our assumption is wrong. Here we assumed that n of P is equal to n of Q, which implies alpha there exists a T belongs to S such that alpha of T belongs to S, which is a contradiction. Hence, n of P is not equal to n of Q. So, similarly here first we assumed that the orientation is del F by norm del F. We can prove these statements even if n is equal to minus del F by norm del F. Hence, at last we can say that either n of P is equal to V or n of Q is equal to V. That is, for each V belongs to S and there exists a P belongs to S such that n of P is equal to V. So the function n is a onto function. Now we want to prove the existence of alpha from AB to Rn plus 1, which satisfies these conditions.